Hello everyone, today we're going to be talking about annual percentage yield. And let's first talk about the idea here. So the idea is annual percentage yield is your effective interest rate. All right, and what we mean by effective interest rate is we have these compounding interest rates on these investments that compound however many times a year or continuously. And we know the APR for that, but what we're figuring out here is the growth of your investment as a percentage of the principal. So all of that interest that's earned compounding the whole year, but taking all of that interest and saying, well, what's the percentage of the original? Okay, we've got two different formulas here. The periodic compounding APY and the continuous compounding APY. And they're both pretty simple. So in both of them, we need R, which is the interest rate. As always, we want it written by a decimal. With continuous compounding, that's all we need. And with periodic compounding, we need the period. So how many times per year your interest is compounding. All right. And with periodic compounding, our formula is that the APY is 1 plus R over M, all raised to the M minus 1. With continuous compounding, it's E to the R minus 1, where E is the irrational number that's 2.71, yada, yada, yada. You always use the E button on the calculator here. So these formulas look pretty simple. We're not going to get into the derivation of these formulas in this video, but you're welcome to look it up online or in the textbook. So these are the two formulas that we're going to be using. And let's go ahead and look at our example. Which investment has a higher annual percentage yield? Okay, so one at 4.7% but compounding continuously, so compounding all the time, or 4.8%, a little higher but compounded only semi-annually, so twice a year. And let's go ahead and transcribe our formulas. So here we're going to use E to the R minus 1. For compounded semi-annually, we're going to use 1 plus R over M, all raised to the M minus 1. So let's fill in our variables here. R is 4.7%, written as a decimal, that's a 0.07. And then we want E to the 0.047 minus 1. We plug that into the calculator, making sure to use the E button on the calculator. And as always in these finance problems, you never want to round off until the very, very end. So we do E to the 0.047 minus 1, and what we get is 0.048122, or 4.8122%. And we'll notice that's higher than our annual percentage rate for compounding. But what's happening is, right, compounding interest builds on itself. So over the course of a year, that ends up being a total of 4.8122% of the original investment, whatever that original investment was. Okay, and with compounded semi-annually, our interest rate this time is a little higher, 4.8%. So 0.048, and M, number of times it's compounded per year. Semi-annually means twice a year. So we fill that in, 1 plus 0.048 over 2, all raised to the M, which is 2, all minus 1. And as always, when we've got a complicated algebraic expression, we want to work inside out. So let's start with the inside first. 1 plus this fraction. Well, we can figure out that fraction. 0.048 divided by 2 will be 0.024. So we have 1 plus 0.024, all of that squared minus 1. And that comes out to be 0.048576, or 4.85, 76%. Okay, so our original question was which one's higher? Well, this one's higher here. So the 4.8% compounded semi-annually wins the day. Has a higher annual percentage yield, but not by very much, only by 0.04%. All right, so there's the answer to that example. And one other thing that I want to point out here, both of these, the APY was higher than the original interest rate. So here we had 4.7% compounded continuously, and the APY was higher than that. The effective interest rate was 4.81%. Here it was also higher, from 4.8 to 4.85. But one thing to note here is that the difference is larger in the compounding continuously. So compounding more often yielded a higher, well, not a strictly higher APY, but a bigger difference from original interest rate to APY. And that is it for today.